Hello, welcome to the class. Today we're going to learn 10.3 polar coordinate. Okay, so firstly, I'm going to give you a little bit idea what is going to be polar coordinate. So for given point in Cartesian coordinate, we say the point is given, the coordinate is given by x and y, right? So the point is given by x and y. But right now, this is called a Cartesian coordinate. But right now, we're going to use r theta, another pair, r theta, to express the same point. And what's the meaning of r? R is the distance from the origin O to the point P. So the length is r, and the theta is the angle from the x-axis to the line OP. Okay, so I'm going to give you the definition. So let's take a look at the definition. Now we fix an origin O. Sometimes we also call that as pole. And an initial ray. So the initial ray is just like OX. So here, okay, initial ray. So we find the fixed origin O and draw initial ray. Okay. And then from O then each point P can be located by a polar coordinate. And what's the polar coordinate? Which is given by r theta. Okay, this is called the polar coordinate. And what is r? R gives the distance from P to O. From P to O, or O to P, doesn't matter. And the theta gives the angle from the initial ray to OP. Angle from initial ray to OP. So let's take a look at the graph. Initial ray and the O, we have the origin now. So if we have point P, okay, and the point is given by r theta. And what is r? R is the distance from O to P. And what's theta? Theta is the angle from the initial ray to OP. So that's the polar coordinate. Okay. So right now I'm going to just write down a point. So before we write down P point x, y, but here we write down r theta. And r is distance. Okay. From O to P. And the theta is the angle from initial ray to OP. And here r can be negative. I will show you. Okay. Now let's take a look at some points. Some example. Right now, so let's see. If the point is 2 pi over 6 for this point, what's the meaning? So we choose pi over 6 should be 30, right? So by here, and if we say this is 2, the length is 2, and here is the point 2 pi over 6. Okay, and this is 1, 2. And we can also express this point by, 2 pi over 6 plus 2 pi. Because pi over 6 plus 2 pi come back to the same point, same angle. Okay, same angle. So let's take a look at another point. 2 negative power 6. So we know the angle negative power 6 should be here. Okay, and the same thing, same length is also 2. So this point is 2 negative power 6. And let's take a look. If we do r as negative 2, so r is negative 2 pi over 6, how to find that point? So we draw the angle first. Power 6 is here, okay, in this one, power 6. And then because negative 2, then we go to the other way, negative. Okay, so here is pi, negative 2 pi over 6. Or we can also express this as what? Positive 2, and what's the angle here? Pi plus power 6, 7 pi over 6. They're the same thing. Okay, and for this point, we can also express this as negative 2, 5 pi over 6. So 5 pi over 6 should be here, and then negative 2 come to the other side. Okay, so now let's take a look at the example 1. So don't worry too much, we will do more detailed practice about this kind of thing. Plot the points. Okay, so we are going to plot several points. So the first one is 1, 5 pi over 4. The second, 2, 3 pi, 3. Number 4, negative 3, 3 pi over 4. So we are going to see where those points are. Okay, so firstly, let's draw the axis. Let's take a look at the first point, 1, 5 pi over 4. Usually we like to find the angle first, then we know where it's going to be, right? Roughly. So 5 pi over 4, which is pi plus pi over 4. So pi plus pi over 4 should be in this position. Okay, and then it's 1, r is 1. So if you say this is unit 1, so we can just stop here. This point is 1, 5 pi over 4. Okay, second point, 2, 3 pi. So 3 pi, you know, that is 2 pi plus pi, right? And 2 pi just one circle, and then we just do pi. So it should be here, and the 2 roughly here. So this is a pi angle, this is angle pi. And then 2, 3 pi is here. Second point. Third point, let's see. Negative 2 pi over 3. So negative, we do clockwise, right? Clockwise. So 2 pi over 3. Now let's take a look at where is 2 pi over 3. This is pi minus pi over 3. So it should be, and it's negative, so it should be here. And it's 2. The length is 2, so it should be this one. The last point is 3 pi over 4. Firstly, we find the angle 3 pi over 4. Pi minus pi over 4, so it should be here. But, you know, it's negative 3, so it's not here. It's go to the opposite way. So negative 3 should be here. Angle is that angle, but r is negative to opposite way. Okay, so that is the plot for the all 4 points. Now you can try those points. Negative 2 pi over 3, 2 negative pi over 3, negative 2, 2 pi over 3. Okay, so I'm going to give you the solution now. but it's good for you to do the problems by yourself. If you look at my solution, pi over 3 should be around here, but it's negative 2. Okay, go to the other side. The second point, negative pi over 3. So, and the 2 should be here. Because this is negative pi over 3, right? And the third point is 2 pi over 3, so should be here, but negative 2. So it's go opposite way, same as this point, the second point. Okay, so that's the answer. Now let's take a look at the relationship between Cartesian and polar coordinate. Okay. Let's take a look at the graph. How we get to the polar coordinate? So we say here is the point P, and it's given by r theta, this polar, right? And the Cartesian is x and y. And what is r? R is the distance from O to P, and the theta is the angle between x-axis to OP. And right now, if we draw a right triangle like this, and you can see here is x, here's y, right? So actually x equals what? If you use r times cosine theta, that is just x. And if we use r times sine theta, that is y. Okay, so from here, we know if given polar r theta, we can find the x and y. And the other way, if we do backward, so let's take a look. X squared plus y squared equals what? It's a right triangle. We know this is r squared, right? Okay. And if we look at tangent theta, that is y over x. So from here, we can get theta is tangent inverse y over x. So I'm going to rewrite this a little bit. I'm going to write down r squared equals x squared plus y squared, and the theta equals tangent inverse y over x. So you can see here I'm going to box those formulas. The first formula means given r theta, we can find x, y, right? And the second formula, if given Cartesian x and y, we can find r theta. So that's the relationship between Cartesian and polar. Actually, they can change from each other. Now let's take a look at the example. Convert the point 2 pi over 3. So you can see this is polar, right? Because r theta, okay? From polar to Cartesian coordinate. Okay, so let's see. R is given, theta is given. So what is the Cartesian? We just need to find the x and the y. So x equals what? R cosine theta. Plug in. R is 2. Cosine pi over theta. So here we do need to know some like a common use the sine cosine for some common angles. Okay, I will give you a table later. So cosine pi over 3 is 1/2. Actually, which is 1. Y equals r times sine theta. R is 2, sine pi over 3, which is 2 times root 3 over 2, so which is 3. So the Cartesian coordinate is 1 root 3. Okay, that's the answer. Let's try this exercise. Same thing, this is polar, x equals this, y equals r sine theta. Just simplify. Cosine power 4 root 2 over 2. Same thing, root 2 over 2. And this is what? Cancel 2 root 2 times root 2, which is 2 divided by 2, 1. Same for y. Okay. And if you want to look at double check answer, you can draw the graph. Power 4 is here, and here is square root 2. And the point is just 1, 1. You can see. Right? So 1, 1. 1 square plus 1 square is 2. And the angle is power 4. You can double check answer. Next, we are going to do backward. So given the Cartesian, we are going to find the polar. Let's see. Example 3. Okay. Represent the point 1, negative 1. This is Cartesian coordinate. Okay, so we are going to change this in terms of polar. Let's take a look at this problem. So here x and y are given. We just need to we want to find the r and the theta, right? And if we look at the formulas here, r squared equals x squared plus y squared. So we can find the r from here. So firstly, let's take a look. What is r? R also we can write down this way. Root of x squared plus y squared. Okay, so which is 1 plus 1, which is root 2. And what is theta? Theta is tangent inverse y over x. Okay, let's write down the formula. And then plug in y and x. So should be tangent inverse negative 1. Tangent inverse negative 1 is, we can do negative pi over 4 or 7 pi over 4. That might matter too much. They are the same thing. So where's the angle? They are all at here. Okay. If you look at this way, it's negative pi over 4. If you look at this way, it is 7 pi over 4. But tangent that value is just negative 1. Okay. So our polar coordinate for this one is root 2 negative pi over 4 or root 2 7 pi over 4. So in the homework, the question may ask you to find theta from 0 to 2 pi. Then in that case, we have to choose this answer. If theta, there's no requirement for the theta, you can write down any one. Okay, any answer. Let's try the exercise. 1 root 3 negative 1. Okay, so the solution, let's take a look. 1 r should be root of x squared plus y squared, and the tangent 1 should be pi over 4. This is polar, and then you can always check your answer by drawing the graph. So 1 is here, right? Okay. And then for the second point, where it is root 3 negative 1, so root 3 negative 1 about here. Maybe here. Okay. And you can see what is the angle. So let's see, r equals what? If we choose positive r, r is root of x squared plus y squared, so it should be root of 4, which is 2, right? And then the angle tangent inverse negative 1 over root 3. Okay, so here is like 1, we know r is 2, and here definitely it is 3 because it's a coordinate, right? Root 3 and 1. And let's see what's the angle. The angle, I think, should be negative if we use the easy one. So it's going to be negative power 6. Right, power 6. So that's the answer. Now let's take a look at example 4. We're going to change equation in polar to Cartesian. Okay. Let's take a look at example 4. Find a polar equation for the circle. What circle? Circle is given by Cartesian coordinate, which is this one. X squared plus 1 minus 3x squared equals 9. So find the polar. In polar equation means in the new equation we only have r theta, no x and y anymore. So we need to replace all the x and y by r and theta. But from here we have to simplify our Cartesian equation firstly. Okay, so let's see. We change a little bit. Y minus 3. Firstly, we copy the equation in Cartesian. Right now, we expand the second term. So y squared minus 6y plus 9 equals 9. And simplify. 9 can be cancelled. So here we have x squared plus y squared minus 6y equals 0. And because we know x squared plus y squared is r squared, right? So here we use x squared plus y squared equals r squared. If you don't remember this, you can always change x into r cosine theta, and the y equals r sine theta, and then simplify. But here, it's better to use this directly. Okay. So r squared, and what is y? Y is r sine theta. So replace all the x and the y by r theta. So actually, this is our polar equation. Okay, polar equation. And if we simplify, this is r minus 6. If we factor r out, sine theta equals 0. That means r equals 0 or r equals 6 sine theta. Okay. R equals 0 just means a point here. So, but this is circle, right? Definitely circle. So we choose that one. Okay, simplified form. If you don't simplify, you can also leave this form. Both are correct. So this means circle in polar coordinate. Now let's try exercise problems. Y equals 1. Circle centered at origin. Okay, let's take a look at those problems. The first one, r sine theta equals 1. You can just leave answer like this. It's a new equation in terms of r theta, right? If we don't simplify, just look like that. The second one, r squared equals 1. Okay, you can also write down r equals 1. So unit circle r equals 1 means what? Oh, sorry, here r is 2. R squared is 4. For this problem, it's 4, right? So the radius is 2. This means all they have the same radius, 2. That's unit circle. Okay, you can do either way, this or that. Number 3, x times y equals 2. So r sine theta, r cosine theta equals 2. After simplifying, r squared sine theta cosine theta equals 2. Okay, they are all polar equation for the given Cartesian equation. Example 5. Change from polar to Cartesian. Polar to Cartesian. Okay. So replace the following polar equations by equivalent Cartesian equations and identify their graphs. So replace the polar equations by Cartesian. And identify their graphs. Okay, two questions kind of. Firstly, find the Cartesian equation and then draw the graph. The first one, r cosine theta equals -4. Let's take a look. We know r cosine theta is x, right? So we just replace r cosine theta by x. So that means x equals -4. And if we draw the graph, where is x equals -4? It's a line. Okay, so this means a line. The second, r squared equals 4r cosine theta. Change this into Cartesian. So r squared, we know that equals x squared plus y squared. If we look at the right side, so 4r cosine theta, so should be 4 times x. Is that correct? So now we move 4x to the left side and combine with x squared. So I'm going to write down x squared minus 4x plus y squared equals 0. Next, we are going to do complete the square method. I'm going to show you how to do that. Okay, so we add one term here and try to make this whole thing into a square thing. So if we look at this form, we know we should add a 4. Because we add a 4 on the left side, we also need to add a 4 on the right side, right? To keep the same equation. Right now, we complete the square. So it becomes x minus 2 squared plus y squared equals 4. If we look at this equation, we know that is a circle. And what is the circle? Centered at 2, 0, and the radius is 2. Right? This is standard form for the circle. So if we draw the graph, here's 2, center to 0, and the radius is also 2. So the graph of the circle looks like this. That is number 2. Number 3, let's take a look. R equals 4 over 2 cosine theta minus sine theta. This looks complicated, but we can multiply by denominator on the right side. So we can simplify. So it's like r times 2 cosine theta minus sine theta equals 4. So we don't have any denominator rational thing function anymore, right? So simplify 2r cosine theta minus r sine theta equals 4. And then replace r cosine, r sine by x and y. So it's going to be 2x minus y equals 4. If we simplify, that is y equals 2x minus 4. And then we know this is a line, right? Okay. Linear function. And this line with slope 2, y-intercept is -4. So something like this. Just roughly graph. Okay. So here we have several exercise problems you can try. The first one, the second, third going to be a circle. Okay, I can tell. Number 4, r squared equals 1. So r squared equals 1 is also a circle. They're pretty easy. I'm going to give you a solution later, so please try those problems by yourself. And then for this section, for this class, we can stop here. And then in the next class, we are going to sketch the polar curve. So that means the curve is given by the polar equation. Okay, so let's stop here.